Okay, so today we're gonna explore first order differential equations and in particular this special case. So experienced people who know how to solve differential equations will first notice that it's not a linear first order differential equation because of the y to the power 4 term, and it's not exactly separable either. So people try to use the substitution method, which is correct. So we need to substitute v equals something. We don't exactly know what to substitute because of the weird nature of this equation. So this is an interesting problem. It was proposed by Bernoulli in 1695 and is hence called the Bernoulli equation, but it was Leibniz who actually solved it, so yeah. Okay, so how the Bernoulli equation is supposed to be solved is the substitution that should be taken is, well, we have a y to the power of n term here. The substitution we need is v equals y to the power of 1 minus such an n, which is 1 minus 4, which is v equals y to the power of negative 3. Per protocol, v prime is negative 3 y to the power of negative 4, and y prime. And to get y prime back out of this, let's do y prime is equal to v prime over negative 3 y to the power 4. Okay, so let's put this back into that equation and we get v prime over negative 3 to the power 4, and then okay, so basically I've rewritten the entire equation, but in terms of the substitution variable. What you'll notice is that conveniently we have y to the power 4 on both sides, and we have a y term here. So we can quickly cancel out y to the power 4 from both sides. And that leaves us with y to the power of negative 3 here, and that's just completely gone. And conveniently, again, we see that y to the power of negative 3 is the v term that we substituted. So that's just that. And some of you may notice, well, this is the perfect way to use the integrating factor method, but after we do some simplification. So let's multiply both sides by negative 3. That term is gone. Okay, so our integrating factors are, which is e to the integral of 1 over x dx, which is e to the ln x. We don't need the plus c for various reasons, but So our integrating factor is x, and our solution is, well, x to the negative 1, because that's how integrating factors work. And then the integral of x, and then times our function here on the right hand side, which is negative 3 e to the x. And, well, let's solve this easy integral. Well, this is v, by the way. Sorry, I didn't mention that earlier, but let's solve this integral to directly find v. We can take out the constant negative 3, and so we're left with this. And if you do a substitution using, if you integrate by parts, setting that as a v prime, then you will get this plus c. You can check that by using it yourself, but if I'm right, that is the answer. So let's do some simplification. So we'll open brackets. That gives us negative 3 e to the x plus 3 x to the power minus 1 e to the x plus c x to the power of negative 1. The negative 3 is gone because that's a constant, and a constant times a constant is another constant, so I'll just leave it as c for constant. Okay, so what we have arrived at is v. We found v. So we just have to find y now. So if we rewrite this, we get v is 1 over y to the power of 3. And, well, this means 1 over v is y to the power of 3, and we'll just cube root that, and we have this. So y is, just copy v down. I need a better pen. To the power of 1 over v to the power of 1 minus 1 over 3. So that's just to the power of negative 1 over 3. And so yeah, we've arrived at y.